That was a great discussion, and I'm delighted to introduce our next speaker now, Tom Siebel. I first met Tom Siebel when both of us were at a different organization. I was teaching at a university down on the peninsula in the mid-1990s, and Tom was nice enough to come to my MBA class over there. And he was running a remarkable company that most of you have heard of undoubtedly, Siebel Systems. It's a company that was recently sold or merged with Oracle, had 8,000 employees, over $2 billion in revenues, 4,500 corporate customers. He also served as the chief executive of Gain Technology, which is a multimedia company, and before that he was a senior executive in a number of positions at Oracle Corporation. He's done a number of philanthropic activities, including chairman of the Thomas and Stacy Siebel Foundation, the Meth Project Foundation, and the Siebel Scholars. Are there any Siebel Scholars in the audience here? If you can raise your hand. No? Okay. Well, he's kind enough to endow a group of Siebel Scholars each year in the MBA program at MIT Sloan. He is now the chairman and founder and chief executive of a really interesting new company called C3 Energy, an energy efficiency and smart grid analytics company, and we'll hear about that in a minute. So this is actually the first time he's spoken to a public audience in 4 years, so please join me in welcoming Tom Siebel. So, Tom, why don't we dive right in and hear a little bit about how you went about starting this new company. I mean, you've been obviously at the top of the corporate mountain in a number of times in a number of very successful ventures. What motivated you to go in this new direction with this company?
In the spring of 2008, we assembled a number of people from around the country. Are you hearing all this echo, or is that just me? Should I move this microphone? Are we okay? We're okay? Okay. Actually, going back to the Bush administration, we started to get interested in kind of energy policy because we thought their energy policy was kind of a little unusual to, kind of occupy the Middle East, and we spent a lot of time at Princeton and MIT and Stanford and Berkeley and Illinois trying to, understand a little bit about energy and climate and what was going on in there, in that area, if anything. And then in 2000, that went on for a few years. And then in 2008, Ed Abbo and I assembled about 50 of our colleagues from around the world, people like Steve Ward, who is the chief executive officer at IBM, Sean Coyne, who is the, he's the CEO at Lenovo, he's the CIO at IBM, Sean Coyne, who was CIO at GE Power, the founding team of Siebel, people from Oracle, SAP, the energy team from McKinsey & Company. Anyhow, there's 50 of us who met during the spring, summer, and fall of 2008 in Woodside. We got together 6 times in the course of the year to talk about energy and climate, and information technology, and communication technology, and where might this come together, and kind of, what did the future look like. And one thing led to another, and then in December of 2008, we decided to start this company called C3 Energy, and the purpose was to basically build a SaaS technology platform that could be applied to the kind of the general problem of grid analytics and smart grid analytics, kind of related to energy management. So now we've been at that, and we thought this would have some interesting societal, economic, and political implications, all of which were kind of good. And so we started I sent out an email on a Friday in December of 2008. We raised $20 million by Sunday, and with no discussion of what the terms were. And we started business in January of 2009.
Congratulations. You mentioned there's a lot of interesting aspects of that company. Let's pick on one of them. You mentioned it's a SaaS company. Your previous projects were in the ERP world. There's a big transformation going on. Those are very different. Tell us a little bit about that transformation, not just in your own personal experience, but how you see it happening and affecting the industry.
Well, it was very clear. Now at Siebel, we were in the enterprise application software business, and we kind of were the CRM market. So that was about applying information technology, communication technology, the problem of sales, marketing, customer service. Now, it was very clear to us that the computing model was moving from the mainframe to the mini computer to the personal computer and then to the internetwork. So we were very much about that, and in 2003 with Siebel version 7, that was the first enterprise application software stack that used the internetwork. And we basically, this is the first time you could have a zero client architecture and move the, and then in 2005, we introduced a product called Siebel CRM. What was it called? CRM on Demand. And that was actually the first enterprise SaaS application ever deployed. And
well, was that pretty difficult to do that transition? I mean, or was it something that you were able to pull off smoothly?
Oh no, it was hard. I mean, we had to do. I mean, we broke ground. We were the first company to break ground in both the thin client architecture and then the SaaS model. It was technically very interesting, and this is just the way it's going. So we were pretty comfortable with it by the time we got to 2009.
Well, we were just talking to Ed, your co-founder. He had a slide. I guess we got it popped up here right here. So maybe this is a good time for you to describe a little bit about your model there. You see the PowerPoint
this is an example of what we're doing. For example, this is an example of the deployment at PG&E. And so this is about in this particular example is about customer analytics. So let me talk about the grid once. Okay, so the grid, we all know what this is, but you know it most of you better than I. But this is everything from the point of generation through consumption. So we generate the stuff. Okay, somebody's spinning a turbine. Okay, it gets transmitted, it gets transformed, it gets distributed, it ends up at a meter, and somebody's consuming it over there. So there's the grid. We all know about that. And when something fails, like the city of New York goes down, they know the city of New York goes down because somebody calls and says, my lights are out. Okay, and then they drive around in trucks with devices. They drive around in trucks and climb telephone poles and things and look in holes in the ground to find what's not conducting electricity. And if it doesn't conduct electricity, they replace it. Okay, and after they replace enough boxes, maybe the lights go back on in New York. That's the grid. Okay, now, in the last decade, the industry has spent about $100 billion, okay, replacing these devices on the grid with things that are machine addressable. Okay, so you have smart meters. And now instead of, for example, at one terminus, okay, and a smart meter will be, basically transmitting a meter reading every second rather than us having to drive back in a truck once a month and get out and read it, okay? So now all the way back through the infrastructure, through transformation, transmission, distribution to the point of generation, we're investing $1 trillion right now, okay, in the next decade. So this is
not your company.
No. We, as a world, are investing $1 trillion in replacing these devices with machine addressable and remotely controllable device things. Okay, this is this is the biggest machine ever built in the history of mankind. This is a big machine. Okay, so what we've been doing in a joint development effort with General Electric over the past few years is building a grid analytics layer that sits on top of this that allows you to see these devices. And now you can see how fast is that turbine spinning. Okay, you can predict failure. You can conduct audits of buildings based on 1 second interval data, and you can see. Our privacy person back here is not going to like this at all. Okay, I mean, we can look into a building and see what the top 10 appliances are and when they're turning off and on, and then implement demand response programs and what have you. But the efficiency of being able to do this. So think about this as the operating system for the grid. So this is what we've been building. Now this is an example installation that we have at PG&E. Let me turn this darn thing off. I'm sorry. So this is about, I think Vivek is here today. We worked very closely with Vivek on this, the people at TIBCO. So this is about big data aggregation, deep analytics, okay, and then an enriched customer experience. On the data aggregation side at PG&E, this is 7 terabytes of data, okay, that we collected from 19 disparate systems that have never talked to each other before. This is like Oracle billing, each meter data management systems, weather analytics systems, product databases. So we collected 20 billion rows of data, okay, about everything they know about 1 million meters, 450,000 customers, 15-minute, 60-minute interval data, aggregate this data, normalize it, federate it, we keep it current in real time. Then we run it through a deep analytics layer, and then it manifests itself in portals. Doug, I need your email address. I want to introduce you to a company, and I don't have your email address. Douglas. Okay, we got to do that. Okay, and then it manifests itself in portals for residential markets, small and medium business markets, and commercial industrial markets, so these people can see in near real time everything there is about their energy dynamics, take advantage of demand response programs, put together energy efficiency programs, distribute rebates. So this would be an example of what we're doing in on what we call customer analytics. And we're doing this at SoCal Edison, Detroit Edison, Commonwealth Edison, Entergy Arkansas, NYSEG in New York, and a number of utilities around the country.
So that's a remarkable vision. How much of that, how far along are you in implementing that? Are there savings happening to customers now? Is that something that's prospective in the next number of years?
So this is production software. And we've invested about 4 years and maybe $100 million building this stack. Okay? And this is production software that's in production number of utilities in the United States. This would be about customer analytics. Kind of go back to my crayon drawing where I talked about, if you can see the crayon on the board, everything we go from, again, generation, transmission, distribution, transformation to the meter. Downstream of the meter is the consumer, commercial, industrial, small, medium business, residential, okay? When you're downstream of the meter, that's customer analytics. Upstream of the meter, so when you're between the smart meter and the point of generation, this is what we would call grid analytics. So this is about power distribution, failure analysis, load balancing, failure prediction, revenue protection, what have you. That's actually the more interesting part. This market is about $1.5 billion market, software market, okay? In 2013, growing at a 24% compound annual growth rate, so it looks like it's about a $5 billion market in 2017. It's one of the more interesting technology problems that are out there. It has everything, huge data, deep analytics, customer experience, social, web integration, cell phone, the whole deal. And it looks like it's an interesting market opportunity.
So tell us a little bit about how you're getting access to the data. You're partnering with the utilities. I mean, because you described these smart devices throughout the grid in different places and even in the consumers' homes. How does that partnership work?
So we're getting the data all from the utilities and all of their systems, and also external information systems that are out there, real-time weather, satellite imagery, commercial information systems about buildings, LoopNet, and what have you, that tell us about, what kind of building it is, how many square feet, these sorts of things, what the use of the building is. So that's where the data are coming from. And so we get it from SoCal Edison, we get it from AESC in Brazil, we get it from General Electric.
And where do you see the biggest dollar payoffs? Is it demand management, consumers? Is it supply management, and which equipment? Is it dealing with when the system goes down, bringing it up more quickly?
Great
Which
question.
of those are the big payoffs?
Great question. And another thing that I don't want to miss. Okay, all of this data in every one of these installations is stored in the cloud. So in the case of PG&E, this is 7 terabytes of data in the cloud. Okay, with in a production application.
7 terabytes just at PG&E?
Yeah, just at PG&E. Okay. And so it is big data. And our partner on the data aggregation side it will be up here next. This is this guy Vivek Ranadive, and Vivek is a very smart guy, and he is a great partner. And I would say this problem would be unsolvable without their participation.
Right. He's the next panelist.
Yeah, Vivek is the real deal. Now, where are the economics of this? The energy efficiency market, okay, this is really customer analytics from the meter downstream, is in 2012 is a $9 billion market. Okay, this is what 39 U.S. utilities are spending on these state-mandated, state-funded energy efficiency programs. This would be, for example, the CPUC in the state of California, for example, mandates that each utility drive 1% of the energy usage out of their customer base every year through 2020. Okay, and PG&E will spend about $500 million alone. We'll spend about $500 million on that in 2013. And these energy efficiency programs would look like residential rebate programs, Energy Star programs, 2 programs that they're doing at Kaiser Permanente and Sutter Health to replace the chillers. So that's about $9 billion. Unfortunately, that's not all software. Okay, and I would say of that $9 billion, probably I would say probably about $600 million of that is in software systems. Okay, now let's look at now we'll go upstream of the meter into all the grid analytics associated with kind of transmission management, theft detection, revenue protection. That's a $750 million software market in 2000. My math really will add up here in a minute. I know somebody's going to catch me. It's a $750 million software market in 2013 and a $750 million services markets associated with that. So it's about $1.5 billion in 2013, growing at 24.9% compound annual growth rate.
Gotcha. So the panel just before you, Tim O'Reilly and others were talking about the sharing economy and new ways of organizing work. Your chart there, complicated it is, it's of course still simplified and has kind of a linear relationship between suppliers and customers. In my neighborhood, I know someone's got solar panels, and one of the things they do is they sell that back to the grid, and I guess other customers then buy it, and so it's a little piece of a sharing economy there where people are both producers and consumers of energy. How does that play? And it seems that the smart meters and the ability to track this would be a big enabler for that kind of.
Yeah, we're very much involved in that, in building the analytics for renewables. So now when the consumers become producers, okay, you need to be able to account for that in your energy equation, and for the load balancing, okay, energy distribution, even the rate at which you're spooling up power generation. So all of this associated with electronic vehicles, solar. And so we're accounting for all that. We're building, one of the analytics products is designed to handle that.
I mean, you talk about this being the biggest machine that people have ever made.
It's the biggest machine ever conceived.
Yeah, but the architecture of it could change. Now that it becomes more intelligent and you provide analytics, you can imagine it becoming more distributive and less centralized. Is that something you see happening, or is it, what are some of the ways that this machine is changing because of its intelligence?
Absolutely. I mean, instead of doing it with arc welders and soldering irons and copper and lead acid and trucks and ladders,
You're right.
I mean, we can reconfigure it in real time in the operations center.
Does that also?
As a matter of fact, we can opt in and opt out, at the residence, and so it gets all dynamically configurable.
Does that make it easier for people to ad hoc add capacity and to do
Absolutely,
that
we bring capacity on in real time. We can detect failures before they happen. We can see devices. You can see, if you look at the signals, you can detect these devices before they're going to fail, and we can reroute the energy. And you can
see a pattern that a generator has.
There's a lot of interesting work being done in signal analysis. A lot of interesting work being done in kind of the signal analysis associated with fine-grained kind of meter data. When you get into 1-second meter data, and now we're actually dealing with some of this data that we're dealing with are 60 hertz cycles, coming from tens of thousands of sensors. So the data are, you do the math on that, I mean, it's big. Okay, and
well, that you mentioned 17 terabytes a little while ago, right?
Yeah, this guy's 7 terabytes. When we talk about 10,000 sensors, we're taking readings on 60 hertz cycles. We're way beyond terabytes.
Yeah, that's. I mean, you do that math, it goes way. So that's
we're
per.
In the yottabytes. We're like off the chart.
And what do you do? Do you throw that away as it comes in, or you can't store that all?
No, you can't store it. You have to look at it as it goes by. So you're looking
just
out of the corner of your plant.
Quickly.
You're looking at the window and just. You can't store it.
And your friends at TIBCO help with that?
These guys at TIBCO, what TIBCO we do is this data aggregation layer. So what made this easy is the Department of Energy mandated a standard that many of you will be familiar with called the Green Button Initiative. And as part of that, they said that utilities have to publish all this data they have in what they call an open ADE kind of standardized XML format. So now that they have to standardize that, with what we do with TIBCO is we can just take this information and then we build a transformation utility based upon TIBCO's bus that allows us to handle all the data transformations from these disparate sources of data and map them into our system, and then being able to deal with the data in real time, conduct analytics, handle the presentation layer, social integration, Facebook, Twitter, and the whole deal.
Right, and when they have access to all that data through the green button and through the kind of analytics you're providing, how do you see their behavior changing? Do you see people changing the way that they use their energy efficiency in the home? Do utilities behave differently in terms of how they generate power? There seems to be a lot of room for acting in different ways, more intelligently. Have you started seeing the behavioral changes? Ultimately, the information is great, but it only has value if it changes behavior, right?
Yeah, I think it's a lot like, there's some parallels to the medical system. Where you get into energy, there's no price signals. Really,
exactly.
There's no price signals, and you get your bill, and nobody knows what to do with that. Well, the future is about, it's very clear, what the computational device is. The computational device looks like this, right? There's no question about that. It's not the, it's not the laptop, it's not a computer, but we'll be providing, people, consumers, it's going to be like the Prius dashboard. So you can kind of see in real time what's going on, whether it's in a residence, whether it's a small and medium business, or whether it's a commercial enterprise.
So when my
see
dad
in real
went
time
around,
what the energy dynamics are, and so you can decide whether to move your foot on the accelerator or not. You know what the economics of that decision of pushing a little harder or backing off the accelerator are, and then you can make a better informed decision.
Run the dishwasher at night or the air conditioning, whatever, instead of just running around like my dad did, turning off all the lights behind us for not.
Also, people now, where we're going with PG&E and these other utilities, so that they can enroll in these demand response programs in real time. They can get, the alerts. They can, turn off the pool pump or whatever it is, in response. And so the behavioral changes are significant. And we go into these markets and we see the energy savings in residential markets might be anywhere between 1.8% and 5.5% a year. So it's significant.
Well, I'd like to open up and get some questions from the audience as well. So if we could raise your hands, and I see one over there and in the back. And while we're waiting for that to get there, just maybe you could say a few words about the frequency of the data. You talk about 60 hertz data.
60 hertz data.
So,
that would be 60 times a second from 10,000 sensors. It's like.
Right. Is there some point of diminishing returns, though? If you get it once per second, is that good enough? Or did you see real value in slicing it that thin?
Oh no, when you get to fine-grained data like a second, when you get less than a second. Today, when they want to do an energy audit on a building, okay, you need, the state of the art in 2013 is you get somebody in overalls with a flashlight and a clipboard, and they go climb through the building, they count the light bulbs, count the switches, all the pumps, and they kind of build this audit of the building, okay? With 1 second or less meter data, okay, you can go in and you can do a much more accurate audit of that building.
You can get like a signature that this is a fluorescent light bulb, this is a halogen, this is a dishwasher.
You can see what they are, you can see when they're coming on, when they're going off, what's going on. So you can do we're working now with the people at Precor and Lawrence Berkeley Labs and GE. We've been working with the guys at Silver Spring and Networks, and we believe that we have a technology where we can do very precise energy audits of buildings without ever entering.
Well, I can see the upside. There's some interesting privacy implications as you alluded to earlier, but let's get a question and then we'll come back to that too. There was a question, I think, right over here. Yes.
Hi, thanks for your talk. My name is Hermeet Gill, and I did mechanical engineering as my undergrad at MIT. I'm currently in the energy industry, part of GE, and I have a bigger question for you, which is, looking at all the different problems in the world, where does energy stand? And do you think a lot of the innovation is going to come from large multinational companies or from innovative and smaller, nimble companies?
Great question. Well, I think that if we were to conduct a poll of the room of kind of the interesting challenges kind of facing the planet in the next 10 years, I think energy would be in the top 5 of everybody's list. So I think it's up there somewhere. The political implications, the climate implications, the social implications, and economic implications are pretty interesting. So I think on most people's lists, it'd be one of the top 5. From my experience in dealing with the giants of the business, all of whom are friends of mine, okay, and the people in the Silicon Valleys of the world, honestly, I think the innovation is going to happen in Silicon Valley. I don't think it's happening in Munich. I don't think it's happening in Minneapolis. I don't think it's happening in the large industrial companies. I think it's happening here. And I think that we're seeing more and more partnering between companies like Siemens, companies like General Electric and ABB with the Valley. Certainly your company is one of the leaders in that space. And you know, I think it's happening here.
So a lot of hands going up here. So I guess there's a mic right here. Yep.
Hi, I'm Mark Chu with PG&E. So utilities are notoriously hard to sell to because they like to move slowly, and even if they like your product, they might do a pilot for 2 years before they actually buy something. How have you been able to be so successful in getting utilities to actually move on wanting to try out your product and do so many trials?
It's a great question. Now, I believe in my professional experience, I have deployed as much enterprise application software into large corporations around the world as anybody on the planet. I mean, I've done a lot of this stuff. And so I've seen everything from impossible to incredibly cooperative, okay? And professional and together and well run. Now, I will tell you that our experience with PG&E was that these guys know exactly what they're doing. Okay, they were incredibly cooperative. What we solved was a very, very difficult problem. We loaded 20 billion rows of data, 7 terabytes of data at the rate of 500 million records an hour from 19 disparate systems that people couldn't even think would ever talk to each other. And every time there was a problem, I mean, nobody ever pointed their finger, they just said, how can we help? Okay, they'd send 6 guys from PG&E down to Redwood City to help us solve it. I mean, this crew we worked with at PG&E, they were unbelievable, okay? And without that, this problem could not have been solved. Now, I will say that not all utilities are that way. I mean, there's another utility in the state of California whose name will remain unmentioned, okay? Unfortunately, I'm sure there's somebody here in the room, so I'm definitely not gonna, but now we brought them into production on December 15th. We started this application with PG&E in March of 2012. It was in production on September 30th. I mean, that's a blink of an eye, okay, for us. I mean, you could spend 10 years and not do this, right? A lot of companies have, okay? Now, there's another company in California who remain unnamed, who we did bring into production over on December 15th, on time, on budget, to the terms of the contract, and it's very successful, but it was like dragging a dead whale over the finish line that was fighting you the whole time. I mean, it was brutal. So I think they vary, and it's just, it's not like unlike other industrial corporations. But I'd say these guys at PG&E, these guys are professionals.
Let me ask a variant of that question. You've had a lot of experience in the past, but also now, how much of this is a technical issue and how much is an organizational and cultural issue? What do you see the biggest barriers to making that vision you described happen more rapidly?
Well, I would say the technical issues are really daunting. I mean, they're really daunting. This is a very, very difficult problem. And without organizational alignment, without executive commitment, and without somebody who's willing to break through all the bureaucratic barriers that are there, it's not going to happen. Okay, and so you need
both.
Everything's got to align. And these are challenging integration problems.
Do you find that people are getting, outside of PG&E, is this something that people are getting? They see that what needs to be done, or is it still an education process?
No, I think it's now, we're not dealing with the IT organization. This is now at the level of the chairman, it's at the level of the CEO, it's in the boardroom, and
they're buying in.
It's important.
Okay, great. Let's get some more questions. Way in the back there.
Mr. Siebel, you're a great businessman, and many here in Silicon Valley respect you tremendously for
Please,
that.
could you
Sure.
speak a little more clearly? I'm having trouble hearing.
I said you're a great businessman, and people...
One more time, please.
Sorry.
But there's a but there, which is, as an MIT major, I have to just get into the math a little bit with you. When you talk about building big, scalable systems, could you clarify what you meant by the 20 billion rows? Because a small company like the one I work for just across the street from where Siebel used to be, collects about 1 billion records in a database every day. Salesforce would collect 10 times that, and so they'd be at 10 billion rows a day. So are you just getting started with the data collection, or did I just misunderstand the scale of the system you're building?
Hey, Eddie, come here for a
We've
minute.
got the co-founder here.
Eddie, you know,
You have
I
the
got to
answer.
fight fire with fire here, you know.
Does that mic work up there?
They wouldn't let me in MIT, so I can't answer questions like this, you know. But we have somebody who can.
Thanks for that. We
Wait,
are
before you speak, what year did you graduate from MIT again?
87.
Okay.
I was in the controls group. I thought I saw Professor Crandall here earlier, but no. So we are. This is just the beginning, if you will, and so the the work that we're doing is going to get tremendously larger. Not just the PG&E's case is 15-minute hourly data, and that's going to drop down to the second level on 5 million meters. There are bigger utilities at 10 million meters, and then the frequency of the data as you go down the grid side to the sensors on the grid. They call them phaser units, PMUs. And other sensors is actually sub-second, as Tom mentioned, 60 hertz data. So the PG&E deployment is really targeted to energy efficiency for customers operating on hourly 15-minute data. But basically the system is built to scale significantly beyond that as you get to second, sub-second data. Yeah.
Great, thank you. Well, we're just about out of time here. Tom, I want to give you a chance to give any sort of parting thoughts or advice. You've had a series of just remarkable successes. Obviously, you know something. You've cracked the code on bringing technology and business problems together in a series of functions, one after another. Can you distill any life lessons or any lessons, leadership lessons that you want to share with us as we wrap this up?
It's really hard. It's very interesting. I see all these people, over the years, and, who are getting all polished up, and these entrepreneurs, and they're starting their companies, and they're getting ready to go to their first show and show their stuff. And, I always have great empathy for these people because I've done a few of these startups, and I was at Oracle in the very early stages, and then Gain, and then Siebel, and now this. And, for those of you who've done it, the sacrifices that people make to do this are considerable. I mean, it's just hard work. And what in hindsight might have looked easy. I mean, Oracle might look easy in hindsight. Siebel Systems might look easy in hindsight. I mean, that company went from 0 to $2 billion in revenue in, I think, 7 years. And it looks easy in hindsight, but now remember, I was there. I mean, it was just hard and discouraging, and things didn't work, and people quit, and customers were mad, and you had to deal with it. And there wasn't any money. And so that's the only thought. It's just, it is, it doesn't get easier. And you want to surround yourself with people who are up to that challenge.
Well, great. Thanks very much. Appreciate that.